Hi, we are Group 4 and we are here to present our project work on the top 10 songs of Spotify artists and their YouTube videos. Our goals are to determine the impact of album releases on Spotify streams and YouTube views, comparison of official and non-official YouTube videos, correlation between Spotify metrics and YouTube engagement, general analysis on YouTube engagement, and the impact of tempo and valence on YouTube likes and comments. For the impact of album releases on Spotify streams and YouTube views, we're going to determine if songs released as singles vary significantly in Spotify streams and YouTube views compared to those released within albums. We will use a t-test for independent samples to compare means between two independent groups. This method is best recommended to use for independent groups to find the averages between the two. Our null hypothesis for both Spotify streams and YouTube views claim that there is no difference in average of streams or views between singles released and those within albums, whereas our alternative hypothesis claim that there is a mean difference in views or streams between singles and those within albums. In applying our t-test samples, our results show that Spotify streams has a p-value less than the significance level. Thus, we can reject the null hypothesis. Whereas the p-value for YouTube views is greater than our significance level. Thus, we fail to reject the null hypothesis. Our bar graph illustrates that there is a significant difference in Spotify streams for songs released as albums, indicated in pink, whereas for YouTube videos, there is not so significant difference between songs released as singles and that released as albums. This concludes that album types can have a significant difference on Spotify streams, but may not have an impact on the YouTube views.
Hi everyone, this is Arvind. My research question would be comparison of official and non-official YouTube videos. In this analysis, we will be comparing different engagement metrics like views, likes, and comments between official music videos and non-official music videos. Along with that, we will also emphasize how exactly having an official video for a song's online presence would impact the views, likes, and comments. So in order to achieve this, we have utilized chi-square test to assess association between official video and views, and then we created a logistic regression model to predict engagement based on video status, and different data visualizations are used for visual comparison. In this slide, we will be taking a look at the distribution of views for official and non-official videos. As you can see that official videos tend to have much more views when it compared to non-official videos. So which clearly states that having an official video is an important aspect to get more views. Along with that, there is a comparison bar chart being plotted between views and mean likes of official and unofficial videos. The same case repeats here, like the unofficial videos have lesser views and comments when compared to official video. After conducting multiple analysis, we were able to achieve the following results. Pearson's chi-square test revealed that there is no significant association found between official video and the likes received by an video, whereas two sample t-tests showed us there is a significant difference observed in mean views between official and non-official video. We were able to confirm the same thing by the visualizations provided in the last slide. And coming to ANOVA, we were able to see a significant difference detected in mean views between the two different groups, the official and unofficial videos. And after conducting GLM logistic regression, we were able to analyze that official video status emerges as a significant predictor of like received. This doesn't only stop at likes. It also includes both comments as well as the views received on a video. and then we were able to create a model to predict if a video is likely to be an official video, and we were able to get to a point where danceability, energy, speechiness, and valence significantly influence the likelihood of an official video, whereas acousticness, liveness, and tempo do not have any difference.
Preliminary analysis of the relationship between Spotify musical characteristics and YouTube engagement metrics. So this preliminary report explores the correlation between musical characteristics from Spotify, specifically danceability and energy, and engagement metrics from YouTube, namely views and likes. The analysis aims to identify if certain musical attributes are associated with higher engagement levels on YouTube. Well, in the evolving landscape of digital music consumption, understanding the relationship between the musical characteristic of songs and their engagement on platforms such as YouTube is crucial for artists, record labels, and marketers. The report represents a preliminary analysis aimed at exploring these relationships, using Spotify's audio feature and YouTube's engagement metrics as primary data sources. Methods. The dataset comprises Spotify's audio features and corresponding YouTube engagement metrics for a selection of tracks. The analysis focused on two Spotify metrics, danceability and energy, and two YouTube metrics, views and likes. The methods employed include data cleaning and preparation. The dataset was cleaned of irrelevant columns and missing values were imputed, with mean values for numerical variables and mode values for categorical variables. The steps ensure the integrity of the dataset for analysis. Correlation analysis. Pearson correlation coefficients were calculated to examine the linear relationship between Spotify and YouTube metrics. Visualization. Scatter plots were generated to visually inspect the relationships between the selected variables. Results. The correlation analysis revealed very weak positive relationships between Spotify's danceability and energy and YouTube's views and likes. Specifically, the Pearson correlation coefficients indicated danceability and views at 0.088, danceabilities and likes at 0.098, energy and views at 0.067, energy and likes 0.062. Scatter plots visually supported these findings, showing a dispersed distribution of points without a clear linear pattern. Interpretation. The results suggest that while there is a slight positive correlation between Spotify's musical features and YouTube engagement, the relationships are not strong enough to conclude that higher danceability or energy directly leads to higher views or likes on YouTube. This implies that other factors, possibly related to content, artist popularity, or video production quality, might play more significant roles in influencing YouTube engagement metrics. Conclusion and future analysis. This preliminary analysis highlights the complex nature of digital music engagement and the limitations of using a single set of features to predict success across platforms. For future analysis, employing machine learning models to incorporate a broader range of variables might offer more insights. Additionally, exploring temporal trends and artist-specific effects could further refine our understanding of what drives engagement on YouTube.
So we will dive into an intriguing aspect of this particular project, which is focusing on how the tempo and valency impacts likes and comments. So the method that I've used is to use regression analysis and visualization techniques that are applied to the Spotify YouTube dataset. So the key findings is that I found some interesting trends, but also some unidentified potential issues with the linearity in the regression models. While the findings can be very valuable and insightful, it's clear that further refinement and further factors that needs to be considered are on the model, so that there is an accuracy that can be that is desired can be gotten. So for the second slide, we're going to dive into regression analysis, diagnostic plots, and the importance of what these diagnostic plots play a role in defining our next steps of this project. So our regression analysis has allowed us to quantify the relationship between tempo valence and likes and comments. The diagnostic plots allow us, particularly the residuals versus fitted and the Q and Q plot, indicate potential challenges in the linearity and the normality of our models. The important part is to understand that these diagnostic plots are crucial as they guide us to the next steps in refining our analysis. So in slide 3, we'll go into the scatter plot. Scatter plots, the interpretation, and the conclusion of the findings of this particular topic is the scatter plots depicting the valency versus likes and tempo versus comments reveal scattered distributions suggesting complex relationships. An interpretation is that we observed that weak positive correlation between tempo and comments, indicating faster tempo pieces tend to attract more comments, but with considerable variability. And in conclusion, while we have gained valuable insights into various factors influencing YouTube engagement, there is still much more to explore and refine to fully understand the complex landscape.
Hello everyone, this is Nikita and I'll be speaking on the next few slides. So I'll start with genre analysis on YouTube engagement, and the approach which I followed was, the first step was to categorize the songs based on the musical features, and then the next step was to analyze the YouTube engagement metrics. And the different methods I used, they were for genre classification, statistical analysis, regression analysis, and clustering techniques. So all these methods were used for different purposes. And for the visualization, the bar charts and pie charts were used. So basically the approach which I followed was an integrated approach. In the next slide, the R codes have been used. So to summarize the R codes, the codes I have provided, basically it conducts an in-depth analysis of the dataset containing the information about the songs on YouTube. So the first step was to load the required packages and the dataset, and defining the dataset based on the song genres and views, likes, and comments. And the next step was to group the data by genre and calculating their total engagement, again based on their views, likes, and comments for each genre. And with the use of another library, the bar plot was created to visualize the total engagement by genre, and then the total engagement for each type was calculated. So the next step was that the pie chart was created to display the distribution of engagement types, again based on their views, likes, and comments. In the next slide, you can see the visualization. The bar plot is constructed and it represents the total involvement by genre. And in the next, the pie chart also, you can see it is generated to show the distribution of all engagement kinds based on their views, likes, and comments. And on the basis of results, it is pretty evident that different computing and statistical analytical techniques have been used, and the statistical methods, they have highlighted the difference in the audience involvement, and the regression analysis have identified the predictors for high engagement, while different clustering algorithms, they have revealed the genres with similar engagement. A few recommendations, and for example, the genre classification algorithms could be more refined, and statistical methods could be more advanced for deeper audience insights. There could be collaboration between music and data experts. For the targeted marketing, different clustering findings could have been applied, and there could be implementation on ongoing monitoring of engagement metrics. Lastly, different resources could be allocated for further research or genre audience dynamics. Thank you. That would be all.